Hello, my name is Sanjeev Venkatesh, and today we're going to be looking at SAT math, problem solving, and data analysis. More specifically, we're going to be looking at two variable data, models, and scatter plots, and as always, we have 5 hard difficulty level questions. So let's get started with our first one. Our first one says, the scatter plot shows a relationship between two variables x and y. An equation for the exponential model can be written as y is equal to a times b to the x, where a and b are positive constants. Which of the following is the closest to the value of b? So let's look at this problem. What do we know? We know that our exponential model is decreasing. So what does that mean? Well, this means that b, give me a second, b has to be greater than 0, but less than 1. And how do we know this? Well, if it's greater than 1, it will be exponential, but it'll be more of an one second. Let me restart that one. It'll be more exponential in this sort of way. Of course, this is a really bad drawing. Please forgive that. But you understand, right? It will be exponential in the positive direction, like this. However, it's actually decreasing and not increasing. If b is less than 0, then what will be happening is it'll be in the negative axis and not the positive one. So we know that it has to be in this form, as I just stated. So the only possible way that it can be like this is with with a of 0.83, since it's less than 1 but greater than 0. Moving on to the second problem, we see this line right here. It says the scatter plot above shows the federal mandated minimum wage every 10 years between 1940 and 2010. A line of best fit is shown, and its equation is y is equal to 0.096x minus 0.488. What does the line of best fit predict about the increase in the minimum wage over the 70-year period? The answer choices are A. Each year between 1940 and 2010, the average increase in the minimum wage is $0.096. B. Each year between 1940 and 2010, the average increase in the minimum wage was $0.49. C. Every 10 years between 1940 and 2010, the average increase in the minimum wage was $0.096. And lastly, D. Every 10 years between 1940 and 2010, the average increase in minimum wage was $0.488. Well, what do we know about our line right here? We know that 0.096 is our slope. And we know that negative 0.488 is our y-intercept. If we look here, the y-intercept is being used in part B and C. Sorry, not B and C, B and D. And we can immediately cross these two out because we know that the rate of change does not at all depend on our y-intercept. Rather, it depends on our slope. So our answer choices must be between A and C. Now this is where it gets kind of tricky. It says a scattered plot above shows the federal mandated minimum wage every 10 years. So some people might get confused by the 10 years and say, C, every 10 years between 1940 and 2010, that average increase is $0.096, right? And in some ways that is definitely true. But the thing is, if we look carefully at the slope, we see that from 0, 0, to 10, it increases by about 1, right? Now this is just a really basic approximation here, but delta x is equal to 10 and delta y is equal to 1. So that means that option choice C is incorrect because it says every 10 years the increase is $0.096, when in reality it's around 1. So that means the answer choice is A. And we can tell this without even using that by looking at the definition of slope, right? Slope is our delta y over delta x, right? So delta y is going to be our final minus initial, and delta x is 70 minus 0. So it's saying, basically a slope is saying in the span of 70 years, it increases by this much, right? Say it's x amount. And then this is equal to 0.096. And 0.096 is our value. Forgive this terrible handwriting, by the way. It's this value where each year it grows by 0.096. And that's how we can figure this problem out. Moving on to the next problem, it states the scatter plot above shows the scatter plot shows the relationship between the time y in hours a certain bird spent in flight and the time and the number of days after January 11th, x. Okay, what is the average rate of change in hours per day of the length of time the bird spent on flight on January 13th to the length of time the bird spent on flight on January 15th? Okay, what is it asking? It's asking the average rate of change from January 13th to January 15th. So basically, what is the slope between January 13th to January 15th? So if we look carefully at our x-axis, we see that it's days after January 11th, right? So January 13th, that means it's 2 days after January 11th. And January 15th is, 4 days after January 11th. So that means plotting these points, looking at what it has been plotted, we see 2, 6 and 4, 15, right? And then we just take the slope of the line that connects these two, approximately this. This is the best line tool I have right now. So yeah. So we have the lines 2, 6, the points 2, 6, and then the points 4, 15. Delta y is equal to 15 minus 6, which is 9, and delta x is 4 minus 2, which is 2. Delta y over delta x is 9 over 2, or 4.5. You can do both in the SAT. Moving on to the next question, we have the scatter plot below shows the amount of energy generated in millions of megawatt hours by nuclear sources over a 10-year period. Which of the following equations which best models the data in the scatter plot? Okay, so what do we know about our quadratic equations, right? So we know that this value right here is going to be your y-intercept. Your c value is going to be your y-intercept. If you look and see this, the curve of the quadratic approximately follows this. And this is around 750, right? So that means we can immediately eliminate A and B because here it's showing negative 745.73. In C and D, however, both of them are positive and far more accurate. Now, what is the next thing that we know about quadratics? Let me erase this one. We know, one sec. Yeah, A and B is eliminated. So yeah, we know that when we have a quadratic, if our A value is positive, that means we have a concave up parabola, right? Or in other words, what that means is it's just facing up. However, ours is facing down. Whenever a quadratic is facing down like this, that means that we have a quadratic that has a negative A value. In other words, A has to be negative, so the answer choice has to be D. Moving on to our last problem, what we have is for x is greater than 0, the function f is defined as follows. Which of the following could describe this function? And the function is f of x equals to 201% of x. So what we need to do is try and express this in terms of an equation. So f of x is equal to 201% of x. So 201% is 2.1%, 2.1 times x. Oh, look what we have here. We have a linear equation, right? And moreover, since our slope is 2.1, which is positive, we know that the slope is positive, and thus it'll be something like this. It'll be increasing and it will be linear. And that's how you solve that problem. It looks a lot more complicated than it actually is. That's all for today. Thank you all and have a great day.